Hi everyone! In this video we're going to talk about what kind of role the unit circle plays in trigonometry. As you remember, a unit circle has a radius of length 1 unit. And that's why, as you can see on this picture, this point is labeled 1, 0, well, because radius here is 1 unit. This point here is 0, 1, negative 1, 0, and 0, negative 1. We also learned that if you pick a point on the circle and connect that point with the center of the circle, that segment will be the radius of the circle. It can also be viewed as the terminal side of an angle in standard position, angle theta. And we learned that sine of angle theta in this case can be found by taking the y-coordinate of the point and dividing it by the radius. And cosine of angle theta can be found by taking the x-coordinate and dividing it by the radius. But when we work with the unit circle, we know that radius of the unit circle is always 1 unit. So that means that in the definitions of sine and cosine functions, we can replace r with just 1. And that, of course, simplifies to simply y for sine of theta and x for the cosine of theta. So we're basically saying that the x-coordinate of the point represents cosine of angle theta, and the y-coordinate equals to the sine of that angle theta. And when you work with the unit circle, that's true for any given point on the unit circle. Their x and y coordinates will represent cosine and sine of the corresponding angle. Let's expand this idea a little bit further. Here's the unit circle again, but now it's labeled with the angles. And I know that I'm looking at the unit circle because I can see the coordinates like 1, 0 or 0, 1. And now as I look at those coordinates, they are more meaningful to me because, as we just said, the y-coordinate represents sine of angle theta and x-coordinate represents cosine of angle theta. So let's say when I look at the coordinate of this point here, 0, 1, and that's the point on the terminal side of angle that measures 90 degrees. That's where this angle terminates. That confirms what we already know, that cosine of 90-degree angle equals 0, and then sine of 90-degree angle equals 1. And now I can quickly identify sine and cosine of angles like 180, 270, 360, and all other angles that terminate on either y-axis or the x-axis. Just be sure to keep the right order. The first coordinate always represents cosine, and the second coordinate always represents sine of that angle. Now let's label more points around the unit circle because we know something that will help us with that. And I'm talking about function values, specifically sine and cosine, for the 3 special angles, 30, 45, and 60. Remember those? We already know what sine and cosine values of those angles are. And that means the following. If sine of 30-degree angle is 1/2, that should correspond to the y-coordinate of the point on the terminal side of the 30-degree angle, meaning over here, right? That's the point. And we also know that cosine of 30-degree angle is square root of 3 over 2. So that number should match the x-coordinate of that point. As I put this all together, well, that should be the ordered pair that we use to label this point over here. Point that sits on the terminal side of a 30-degree angle. Because of the symmetry of the unit circle, once we identify the x and y coordinates of a point in quadrant 1, these coordinates can be duplicated around the unit circle at each related angle measure. In other words, we can identify the coordinates of a point that sits on the terminal side of angle that measures 150 degrees, the related angle. And because of the symmetry, the numerical parts of the coordinates will be the same, we just have to adjust the signs. We know that in the second quadrant, the x-coordinate has to be negative and the y-coordinate has to be positive. So that's how we're going to label this point here. And that's how we're going to label points that sit on the terminal side of angle that measures 210 degrees and then 330 degrees. In quadrant 3, both coordinates are negative. In quadrant 4, the y-coordinate is negative. And as soon as we label those points, we once again going to remind ourselves that those points represent sine and cosine of the corresponding angles. This means that right away I can tell you that cosine of 210-degree angle equals negative radical 3 over 2. And I can tell you, let's say that sine of 330-degree angle is negative 1/2. Now let's use the same idea for angle that measures 45 degrees and all the related angles. So since sine and cosine of 45-degree angle are both radical 2 over 2, that means that this point here I should label as radical 2 over 2, comma radical 2 over 2, right? X and Y coordinates. But because of the symmetry of the unit circle, I can add 3 more coordinates around it. And the only thing I change as I go around, I just adjust the signs of the coordinates, meaning positive, negative. And with all that, now I can determine cosine and sine values of all angles related to 45. And finally, 60-degree angle. Based on the sine and cosine values that we already know, we're going to label this point here, x-coordinate is 1/2, that's cosine, and then radical 3 over 2, that's sine value, so that's the y-coordinate. And of course, I'm going to label the other 3 points that will correspond to cosine and sine values of angles related to the 60-degree angle. So now you know the meaning of the points on the unit circle and how they're related to sines and cosines. So it's time to practice, and in the next video we'll do a few examples.